Hello, Internet. How are we doing? We're back here. No coffee today, unfortunately. But we have our setup from the last video. So we have our Fibonacci sequence here. We now have a file, a C file that we were messing around with last time. And we have our terminal. We're kind of in a new machine setup. But I'd like to take the first couple of minutes or so just to get that hello world to come back because I had to switch up my machine. So let's do that. All right. So start by creating a main function, which most programming languages have some sort of entry point from the rest of the system to execute the program that you're writing. And many times that gets initiated in your main function. So we'll just create a good C main function. We'll go ahead and printf hello world, and we'll add a new line character. So the backslash escapes any character after it. And that is just a special character that tells the computer to go to the next line in the terminal and standard out. And then we are going to return 0, which I believe is the success exit code. Now, if we save that and we gcc Fibonacci.c, we're going to get that same error because we need to actually import this function from the standard library. There we go. So now we should be good. All right. Now if we do /a.out to execute this executable file here, boom, hello world. There we go. All right. So we're back to where we started. However, I've run into a problem. I no longer know what exactly we're going to do with this Fibonacci sequence. Yeah. I guess we could maybe make some kind of spiral in the text editor. That seems kind of boring, it's already being done here, so I kind of want to do something creative with the Fibonacci sequence. Maybe if we had a really large text. Okay, so picture this. We have a very large text, like an entire book. Okay. And then we say, create a new book based on all of the words in the book, but we're going to index them based on the number in the Fibonacci sequence. Okay, so that sounds kind of cool. So let's give that a shot because that sounds kind of cool. All right, let's see here. Open source book. Okay, open source book PDF. Gutenberg.org. I think I've heard of this. Ooh, you know what I wonder? I wonder if they have meditations by... No, it doesn't look like... Oh, they do! Marcus Aurelius. Okay. Let's see here. Doesn't look like they have. What's this? It was an EPUB file. This okay, this is kind of interesting. Oh, so here's the first book. My grandfather Verus learned the gentle and meek. Okay. File. I don't even know. Like print, save a copy. No. Okay, here's another option. Let's look for Meditations Marcus Aurelius file type PDF, I believe is how that works. Or file type TXT. Whoa. Okay. Oh, it's all in like different languages too? Okay, let's see here. Full text. Come on, don't give me all these languages. I just want English. Give me English. English, English, English. EPUB generate. So odd. All right, maybe we'll just do a single book. Book 1. Book I. Huh. Okay. So, wow, this is not the best quality. Okay. This is an interesting idea. Okay, so but I feel like it's going to grow so quickly. You know what I mean? Okay, interesting idea. Book. That's just it. Maybe let's see what AI can do for us. All right, Chat GPT. What do we got here? Okay, signing into some Chat GPT here. Continue with Google. There's Ragenblad. Okay. Okay, let's go. What are some interesting patterns with the Fibonacci sequence? Yeah, golden ratio. Okay, spirals in nature. Pascal's triangle. Wow. Okay, there's some in music. Okay, Fibonacci's in stock market. Whoa, population growth. Okay, then. You know what? I have an idea. Let's do this. Okay. We are... I like the idea of population growth. Sounds kind of cool. Let's see how we could how could we represent population growth? Maybe with like stick figures. Okay, so let's see. Like a stick figure might look something like. Also, I think you can do like, yeah. Okay, so what's a good stick figure? Let's see. Maybe. Oh. No, maybe I. Maybe pipe. And then maybe carrot. Oh, maybe O T. Yeah, OT carrot. Okay. That's a pretty good stick figure. Maybe another carrot or I don't know, an underscore for like a little hat. No, that's good. OT carrot. Okay. That's our stick figure symbol. Okay. So I think the essential idea here is we're going to kind of like print out these people based on Fibonacci. Okay, and we're going to do a grid of them. Yeah, let's try that. Okay, so let's see. Int. Let's see. Calculate Fibonacci. Sounds like a good name. Fibonacci number. Okay, and let's give it an index, which will be of type integer. Okay, and then let's do while index is greater than or equal to 0. So while is nice because it's a loop. It'll do the same thing over and over again until this condition here is no longer true. It's false. So then we're going to do decrement our index. And we're going to say, maybe so we'll say int Fibonacci number equals 0. Okay. Fibonacci number. Because we have to, this is where it gets interesting, because we have to keep track of kind of like a window here, like the two of them, and then we got to pretend that 0 is back there. 0 and 1. 0 and 0. Interesting. This is where I could use some coffee. Yeah. Could also use some help. I could use some big time help from people, like if you're watching this video, sometime I could use your help. Love getting help with coding, man. It's how it all gets cool, man. Or person gets real cool when you have help. Okay, let's see here. So, got Fibonacci number. Man, this is tricky. Okay. So I'm doing something I don't always like to do. I'm coding before I've tested it. Sometimes I like to write test functions before I code it, but I like to get the ball rolling too. So, okay. Yeah, you know what? We have time. We have time for tests. Okay. Okay, so let's do that because I'm getting stumped here. Okay. So tests. So void test, and then we're gonna say, actually, we will cut all those and we'll put them down here, and then we're gonna say okay, so first thing we're going to test is that, okay, let's say we say, okay, calculate Fibonacci number, right? Oh, interesting. Real quick, I just noticed that I don't have all 80 characters available here. So I'm actually going to move this terminal to the right. All right, let's see if that's over here. Yep, it's right here. Okay, that's pretty good. Okay, and then let's make that full screen. I just like to have a full 80 characters. Okay, so thanks for bearing with me. Okay, so we're going to say if we calculate with the 0th index, okay, that should equal 0. Okay. Now let's surround this in parentheses because order of operations in C can be very tricky sometimes, in any programming language for that fact. So if we get that, let's printf success, else printf fail. Okay, let's just let's pass this test first, and running tests. New line. Test. Okay, so we're going to do a little shorthand here. We're going to compile our code into ones and zeros so that the computer can read it. So we're going to do that by doing that. And then directly after that, we are going to execute that file with the ones and zeros. So Fibonacci.c has all of our code that we can kind of understand, for more or less understand. And then this a.out file has all the binary in it. And what's crazy about that, let me show you what that file kind of looks like. If we try to open it, it's just like gobbledygook. I mean, like, look at this stuff. Some of it is kind of like English, but not all of it. It's all pretty nasty. So, but hey, the computer gets it. All right, that's what we're doing here. It's all for the computer. All right. The only thing I don't like here is that there's a missing new line. So let's throw some new lines in here. And another new line. Oopsies. And now we've surpassed our 80 character limit. So I like to put those on another line. Okay. Perfect. Okay. So it looks like we are implicitly returning 0 somewhere in here. So, let's just return Fibonacci number just to be explicit. All right. Let's add another test. Okay. So, So this 0th index here, so 0 for this index really corresponds to this index of the whole list of numbers. So the 0th index, which that value in the Fibonacci sequence just so happens to be the value 0. So that's why our test is passing for 0. Should be 0. Now for the first index, we want 1. So let's just do that. Let's do 1 and 1. Okay. Because we want the 1 index to equal the value 1. So let's see here. Dang. Okay, so not quite there yet. Okay, so this is where we have to start implementing the code. Now, another condition why I'm using this while loop is to keep our functions small here. So, I'd say ideally this function should only be 50 lines long. That's how you keep a clean function. Okay, so let's see. How are we going to make this pass while keeping it clean? We need to get the number 1 for an index of 1. Okay. So here's an idea. Maybe we say let's have an increment equals 1. Okay. So we're going to say while our index is greater than or equal to, let's actually do 1 because we're defaulting it to 0. So while our index is greater than or equal to 1, we're going to want to say Fibonacci number plus equals increment. Okay. Interesting. All right, let's give this a shot. Look at that. We passed. We passed both test cases. All right, let's make another test case. All right, now when index is 2, what should our value be? It doesn't really change. Okay, it doesn't really change. It's pretty much just 1 again. So we've got a mirror here, right? Well, we're trying to find this number, right? And it's going to equal our current Fibonacci number plus the previous Fibonacci number. Okay. So we need to also keep track of our previous Fibonacci number. Does that make sense? Doesn't really seem to make sense. Previous Fibonacci number. Okay, well let's give it a shot and see if it works. Okay, so previous Fibonacci number equals 0. Okay. And then we're going to have to say, because right now I think this is going to fail. Yeah, we have a fail. Okay, so let's see here. Previous Fibonacci number, This is getting really complicated. I almost wonder if we leverage lists. Or no. Maybe we don't need increment. If we have previous Fibonacci number and maybe this is final Fibonacci number. See, okay. Control V, final Fibonacci number plus equals previous Fibonacci number okay. Problem with that is they're both 0. You know what I mean? They're both 0. So then how do we start this? 0 plus 0. We can't increment anything to get, and then we get 0. I feel like we start with 0 and 1. You know what I mean? So let's say this is a tricky one. Well, let's just get all the tests to pass first, and then we can worry about optimizing. Okay, so 0 and 1. Maybe we'll just do this. We know this is the first one. We know this is the second one. And then let's say int final Fibonacci number is equal to first plus second. Okay, this is interesting. Okay. Also, white spaces don't really matter as much in C. I know they do in Python sometimes, so it's kind of nice if you want to keep things in that 80 column limit. You can move them on to the next line, and that's okay. All right, so we've got these three things. So we know what the first one is. We know what the second one is. You know what? Maybe we just say the final one is the first Fibonacci number. Is the first Fibonacci number. Okay. If index is greater than or equal to 1, then we just need to add, we need to say final is equal to first plus second, and then we need to say first Fibonacci number is equal to second Fibonacci number, because we're kind of shifting our window. And then we're going to say second Fibonacci number is equal to final Fibonacci number. Oh my gosh. And we decrement our index, which we declare up here as a parameter. Hey, y'all, I think we figured it out. Oh my goodness, this is amazing. Oh. We have a compile error because this is not a variable declared in the scope of this function. We need to return final Fibonacci number instead of just Fibonacci number. Okay. Dang, we were so close. We did fail the last one though. So we didn't get 2, huh? All right, let's do some debugging here. This is when we leverage printf. Okay. I think you can do like %d for a decimal. And then you can do final Fibonacci number, I think. let's give that a shot. This is just me thinking way back into my school days of doing this. So we got 0, 1, 3. Okay, so we got 0, 1, 3. Oh, maybe we don't want to increment. I think we just want to assign. All right, there we go. 0, 1, 2. What is first? First Fibonacci number. First Fibonacci number plus second Fibonacci number. It's kind of like a shifting algorithm, it seems. Also, I have no idea how long this video has been going on for. Let's see. Just having fun with it. So we kind of have to shift. All right, well, I kind of like the idea of potentially opening up a Google Doc here or something. Just call this like Fibonacci. No, thank you. Fibonacci drawing board. Okay. So let's see. All right. So when the index is 0, well, we have 0. Okay. So 0 plus, how do we get 0? 0 plus 0. Okay. So 0 equals that. Okay. Now how do we get 1 of something through addition? Because that's what we're doing, is we're adding plus 0. Okay. And then we're going to say, well, 1 equals 1 plus 0, right? Because this is the sequence. We need to go 0, 1, 1, and then 2. 0, 1, 1, and then 2. Interesting. Okay, and then 2 equals 1 plus 1. Okay, so I wonder if there's a different way to do this. You know what I mean? I've got an idea. What if we did like -2 plus 2? That gets you 0. And then like this is kind of a funky way to do it. And then if to get from here to here, you have to do 3, add 3, and then -2. So you could try like 3 minus 2 or something. Oh, wait a second. Okay, so we have 2 minus 2, 3 minus 2. Okay. Now we need to do something almost equivalent. I think this is just too hard to make it like seamless. That's probably the beauty of the Fibonacci sequence, is that it's so magical from the beginning that there's no way to express it with math, because we're just too close to 0 right now. We're just way too close to 0. to express anything that would make sense. So I think we have to hard code the first 3 answers to this. You know what I mean? I think I'm going to resort to that because, I mean, maybe somebody else has figured something out and spent the time, but I sure can't. So we're going to do some ifs in here. Okay, so we're going to do if index is less than or equal to 0, we're going to grab so int okay, so we're going to come back up here. Final Fibonacci is equal to first, we're going to call it 0. Okay. Okay, so if, if it's, well, let's just say if it's equal to 1. Okay, if our index is 1, final fib equals 1. Else if our index is equal to 2, I guess we could, that's kind of convenient, is we could actually condense these into a single statement. So what this says, this is an OR operator, a Boolean OR. So what it's saying is if our index is 1 or our index is 2, then set the final Fibonacci number to 1. Okay. Otherwise, if index is greater than 2, okay, this is where the magic starts. Okay, so this is where it goes, okay? So otherwise, if our index is greater than 2, then we're going to say I think I shouldn't really count down with the index, Well, I guess I could. So while index is greater than or equal to, or just greater than 0, okay, we're going to say we'll say int previous Fibonacci number equals 1 and final Fibonacci equals 1. Then we'll say final Fibonacci plus equals previous Fibonacci number, right? And then we'll say previous Fibonacci number equals final Fibonacci number. Yeah. And then we'll do another minus index. Okay, so I did have to kind of recode a lot of this to make it make sense in my head, but I think we're in a good place with it. So let's come back here. Okay, so we failed the third test initially. Ta-da! We passed the third test. All right. That's awesome. That is awesome, dude. Okay, so now we're gonna do a couple more of these tests and then be ready to go to attack the bigger challenge of making a population. I like that. Okay. So if the index is 3, we need 2. So here's 0, 1, 2, 3. 4, we need 3. 5, we need 5. So 4, we need 3. 5, we need 5. 6, we need 8. So 6, we need 8. And I believe, just off the top of my head, that 11, we need 89. 89. That's just because I tried this earlier. And 12, we need 144. Let's just do that one. 12, we need 144. Okay. Let's give it a go. Oh, bummer. Oh, that's such a bummer. Okay, we're probably going to have to come back to this one. Video's been going pretty good. Yeah, I really hope this is fun for everybody else too. I love feedback. So if you have any time, please leave a comment, if anything, and I'd love to read it and tailor these videos a little more towards our community that we could start building. And I'll be coding more, drinking coffee more. I'll also be roasting coffee, so I'll be posting some videos later on that too. But that's going to do it for today. See you in the next video.